Hi guys, so today we're going to look at solving simultaneous equations, but this time we're looking at solving simultaneous equations between quadratic and linear equations. So just a bit quick important points that we need to know. We need to know that a tangent, which we looked at in circle geometry last year, is just a line that touches a parabola or circle at only one point. So if you look at this roughly drawn sketch over here, you can see that this line here touches it only at this point here, so it's a tangent, whereas this other line, which cuts through the parabola at 2 points, is not a tangent as it cuts multiple times. Okay, so to solve a quadratic and linear equation simultaneously is just to find the points at which both these lines intersect. That is, where do they have the same value? So it's just solving simultaneous, and we're going to use substitution in this case. So first example is find the points of the intersection of the line y equals negative 2x plus 4 and the parabola y equals x squared minus 8x plus 12. So it's already in a format nice for substitution, so if you label them 1 and 2, you just sub 1 into 2 and you'll have negative 2x plus 4 is equal to x squared minus 8x plus 12. And now it's just a matter of solving this equation for x as we've eliminated y. So we need to get, just like normal, get all x values over to one side. So we'd add on 2x and take away 4. So 0 is equal to x squared. Negative 8x plus 2x is negative 6x. Take away 4 from 12 is plus 8. Okay, then we just need to do the add and multiply. So what adds give negative 6 multiplies give 8, negative 2 and negative 4. So it's equal to x minus 2 and x minus 4. Therefore, x is either equal to 2 or x is equal to 4. So that means that these two lines intersect at 2 and 4. So when x equals 2, y is equal to, go back to the linear equation, y will be equal to negative 2x plus 4, in this case negative 2 outside of 2 plus 4, just substituting in this value here. So that's negative 4 plus y is equal to 0, and when x equals 4, y is equal to negative 2 outside of 4 plus 4, negative 8 plus 4, y is equal to negative 4. So therefore they intersect at 2, 0 and negative, positive 4, because that's the x value, negative 4. So if we were to roughly graph that over here, so y is equal to x squared minus 6x plus 8, that would roughly go around about here. You could go through the working out of graphing that as well by yourselves, that would be a good thing to do. And the straight line, we know it intersects at 2, 0, which is about here. And 4 minus 4. So this probably isn't to scale, which is why it's important to graph correctly. And then it's just a straight line that hits these points. So this is why you need to use a ruler. It's hard to do on the computer, but you guys would be doing that. Okay, and that is how you would graph this if you were asked to graph it as well. The only step there is you'd probably take time to actually find the x-intercepts and y-intercepts of the parabola and also the straight line there. Alright, once you have a look at this question here, prove that the straight line y equals 1x meets the parabola y equals x squared minus 3x plus 2 only once, and we'll go through that in the next video. Hint here is you still want to use the substitution method to find how many times they actually meet and where they meet.